haven't taken the class survey, you are now failing this class. You have 0 out of 1 points. If you took the class survey, congratulations, you have 100% in this class. You are amazing. Don't worry, we'll have some more assignments. That's not the only thing we'll do in this class. Discord server, I think everybody pretty much has done that. If you didn't change your nickname, then I probably did. And a few people have posted their GitHub usernames directly in, which is nice. Most people were able to log in yesterday using SSH. Most people changed their own passwords. And most people did GitHub. So at the end of today, again, today's class, me talking, is going to be relatively short. So if you have not got any of this done, there will be time for me to help you at the end of lecture.
I just started now.
Great. So again, if you want to install MySQL on your machine and you'd like help with that, you can also stay after lecture and I can help you with that. And then once you get into phpMyAdmin, you're going to log in with your own ID as the username and password again, and then just click on change password and you can change it to whatever you want. All right, so the overarching theme of this course, you will hear me say these words over and over and over again. Welcome to software development. One of the things that you are going to do as a software or database or whatever professional in technology is people are going to ask you for your opinion. The analogy I like to give is, why should I pay a software developer, $100,000 a year just to copy and paste stuff from Stack Exchange? It's like, well, you're paying me $1 to copy and paste stuff from Stack Exchange and $99,999 to know which code to copy and paste from Stack Exchange. So everything has multiple solutions, right? This is not just computer science, but especially in computer science, there's always a million different ways to do things. And how you want to do it depends on what you're trying to accomplish. So all of you are now experts with SQLite. Yes, everyone has taken Dr. Anderson's course, right? So which is better, SQLite or MySQL? Hey, you guys are already on board. Excellent. It depends, right? So SQLite is awesome. Don't get me wrong, it is an amazing program. It is an amazing piece of software. You can look at the source code yourself if you want. It's open source. You can learn a lot from looking at open source code. But the main thing that I want you to take away from this diagram is that every application uses its own little SQLite database. So it is one file. This is both the power and the limitation of SQLite, is it is one single file with data inside it, which makes it very portable, very fast, very small. So what do you think a really good use for a fast, small, portable database is? Your phone, exactly. Not just your phone book. Every app on your phone can use a SQLite database. Both an Android and an iOS, SQLite comes with the software. Small, fast, portable. So it's really nice because every app on your phone can have its own little data storage independent from all other apps on your phone, right? You don't want to have one giant database on your phone that all these apps are trying to read to and write from all the time. That would just be a horrible mess. You'd have bad programming messing up good programming. It would be horrible, right? So SQLite has it's an individual file for every database. Very low startup resources. I can't remember off the top of my head. You can look it up if you want. It's like you can have a SQLite file that's like 10 kilobytes or something. Like it's ridiculously small. There's no configuration, right? You guys learned this in that class. You don't have to set up anything to run SQLite. You literally just type in SQLite and it just works. You can just open it like a file, store stuff in it, read stuff out of it. It's super easy to use. Slight downside, there's no authentication, right? You didn't have to log in to SQLite to get any of the data, right? You just open it like a file. If you have access to it, you know, in the operating system, you have access to all its contents. There's no authentication. There's no security in SQLite. And there's no write concurrency. So all of you can read from the same SQLite database at the same time. It's just like a file that way. So, you know, if you go onto a computer, right, if you all connect to the same server at the same time, then you can all read the same file at the same time. There's no limit on that, almost no limit on that. But you can't all write to that file at the same time. So this is one of the downsides with SQLite is that if you want to have multiple applications writing to this database, you can't do it at the same time. There are software ways around it, right? A lot of people have used SQLite and want to do this, and so there's little blocking mechanisms. So it looks, as far as the human is concerned, as though you're writing at the same time, because it's only a few milliseconds, right? If I write and then you write and then you write, and the writes take 10 milliseconds, none of us are going to notice the 10 millisecond delay, right? But in reality, it doesn't happen at the same time. And that matters when you start scaling up to like millions of users, right? A million users trying to write data, 10 milliseconds each, all of a sudden you've got 1,000-second delay or 10,000-second delay or whatever, you know, math, right? But the point is, it becomes an issue when you start getting to scale. So that's why I say it's somewhat scalable. It's also, you know, we're going to get into a lot of stuff later in the course about replication and multiple databases backing each other up and stuff like that. Trying to do that with SQLite is hard. It is harder than it's worth. So you can do things like sharding, which again, we're going to get into much later in the course. But basically, like, if I know that you two are almost never going to use the same data, I can split my SQLite database into two, and you're just writing to one and you're writing to the other, and then I kind of synchronize them in the background with fancy software. So it looks like one big database because you can both read from it, and when you write to it, it's actually two files. So anyway, blah, 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 blah. Point being, you're not going to use SQLite if you're making Twitter or Facebook, right? If you're making an app to check whether you need to fill your cat feeder or something, then it's a great, you know, it's a great database for that. All right, so on the other side is SQL Server. This is the most popular database in the world, like I said, for websites right now, and actually for a different kind for enterprise database. But I'm going to do some hand waving and pretend that they're all the same. Because for this comparison versus SQLite, they are the same. So generally, what you do is you have this database server, which is one giant machine, and it runs 24/7, 365 as a service in the background, right? So it's not just one file that you open and write to. It's a service that you connect to, and the database manages all those connections for you. So if all of you connect to the database at the same time, the database will just handle that for you. You don't need to worry about reading and writing into files and stuff like that. The database does all that for you. Of course, what that means is you need a reasonably large server to do it. I mean, well, reasonably large, right? This computer now has, I don't even remember, like 16 gigs of RAM or something, or no, not RAM. Has probably 4 gigs of RAM, has like 128 gig hard drive in it, right? You could run MySQL on this computer if you wanted to. So this is all relative again. But the point being, if you want to run a real database for hundreds or thousands of users, you need a big server, and it's gonna, like the database, MySQL, for example, I think takes 600 megabytes to download and install. So that's not huge, but it's not small, right? I mean, it's still pretty big, just without any data in it, right? That's just the service itself. So it takes a lot of initial resources, but then it's very, very highly scalable, right? You can have millions of people reading and writing from this database, and it's not even going to blink an eye, right? That's what it's for, right? And the resources required for 1 million people reading and 1 person reading are about the same. So this SQL Server is designed to be more enterprise-friendly than SQLite. It's designed to have lots of people using it. And with that, obviously, comes security issues. Right? I don't want everybody reading anything from my enterprise database. If I'm at Mayo, right, I don't really want patients logging in and reading each other's data. That would be a bad thing, right? At Mayo, in fact, the security is so tight that if I'm a doctor, I can't even see patients' security that I'm not, patients' data that I don't have specific access to. And again, we're going to get into that more later in the course, but that is the way you, as future database administrators, want to handle your data. You want to lock everything down and then only release security to people that need it. And so that's why this is a good thing for enterprise databases. As I mentioned, designed for concurrency and speed, so you can have millions of people connecting to a MySQL database with no problem. It's very, very fast because of the underlying data structures, which we'll get to again later in the course. How many people have taken a class on data structures? Oh, yes, that's great. So when I say things like binary tree, you guys, yeah? It's not like I know some of those words. All right, and then highly scalable. So again, we're going to talk about this more when we're comparing SQL servers to NoSQL, to MongoDB. But you can do things. I don't think I put a slide. Oh, yes. Wait, what just happened? Ah. Everything's falling apart around me. I'm hoping this is still recording. I'm trying a new system to record lectures, so hopefully it's working. All right, well, let's pretend it is. So highly scalable, right? You can literally set up a computer with MySQL on it, set up another computer with MySQL on it, tell them that they are supposed to replicate to each other, and like turn them on, and they'll just do it. I mean, it's a little more complicated than that, but it's basically that easy, right? So you can literally set up a backup database in less than a day, right? Whereas trying to figure out how to do replication and backup with like an SQLite database would be a long, complicated process. So again, this situation is designed for enterprise level data storage. And my little diagram here, the point I was trying to get across is this green blob here is one computer. So it's running the database as a service, and then applications on that computer, like a web server, can connect to that database. You can also have applications outside that server connecting to this database. I'm going to tell you some reasons why we don't generally want to do this. But you can, right? You can write an application on this computer and have it connect to a database on that computer. So, for example, you folks are going to write applications on your laptop and connect to the production server on the mrbartus.com. There are pluses and minuses there that we'll get to, but it's easily doable. All right, so here are some uses for SQLite. As I mentioned, I didn't actually mention. Embedded devices, Internet of Things. So anybody have like a fridge that tells you when you're out of milk, right? Thank God none of you have a fridge that tells you when you're out of milk. I have mixed feelings about IoT, and by mixed, well, I don't want to swear in the second lecture, so maybe later on in the year. So embedded devices like fridges that tell you when you're out of milk often use SQLite for this reason, right? You can just create a SQLite DB, right, and it's really small, really fast, and doesn't need security, which apparently IoT does not. Your phone, right? So if you have an application that just needs to store some data locally, it's a great way to do it. Even applications that you write for your PC or whatever, if it's just like local kind of stuff, local storage, it's better than files for most things. Oh, I should have a slide why it's better than files. Well, trust me. Small websites, and here I have an asterisk because, again, small, what does small mean? The SQLite website itself runs, not surprisingly, on SQLite. So they claim that they can go up to like 100,000 concurrent users or something like that, reading files. So if you have a website that is mostly read-only, so like an informational website, like a blog, right? SQLite would be great because there are not many people writing to your blog, right? Not million. I mean, I'm sure you all have millions of readers, but probably not millions of writers, right? And so SQLite it would be fine for that. So small, I should have put the asterisk by small. It depends what you mean by small, but again, it's great for stuff like that. Local data analysis. So say you work at the clinic. I'm going to probably use that example a lot. And you have a bunch of data in Excel Word spreadsheets, and they're all getting really messy, and you hate having to pass them around because people mess them up, right? Super easy way for you to clean that up is you can actually, literally, there's a tool that will slurp in Excel data and put it into an SQLite database for you. And then you can just run SQL commands, right? So think about how much easier it would be to try and get data from a bunch of spreadsheets if you could just use SQL commands in an SQLite database, right? It'd be so much easier than trying to write VBA script or whatever it is these days. So again, it depends. If you have one spreadsheet, who cares, right? But if you have 40 spreadsheets and they each have thousands and thousands of columns and rows in them, just put it in a SQLite database. Awesome, away you go. And then you can just send, and if you like it enough that you write a little Python program to do some analysis for you, for example, you can put your Python program and one SQLite file on a thumb drive and hand it to your co-researcher, and away they go, instead of emailing or sharing spreadsheets back and forth and trying to remember where everything is. Enterprise data, so if you have something like this, right, some big application that lots of people use, and they're constantly contacting a database server, if you have thousands and thousands or millions of people in your enterprise, your IBM, your Salesforce, or something like that, you can have your app store your data locally, and then like at the end of the day or every hour or whatever, synchronize it down to a big enterprise database. So some people use it as sort of a local cache for data. And then this kind of what I was saying for the Mayo example, you can use it instead of, if you have a little app, instead of writing to files, reading and writing to files, reading and writing from SQLite is actually faster than reading and writing from large files because of the data structure that is in place already, right? If you think of a file, it's like a giant array, right? Searching linearly across an array is O(n) for anything, for everything, right? Whereas in SQLite, you have a nice little data structure that will find stuff faster for you. And then obviously education and training, right? So in that class with Dr. Anderson, you didn't have to set anything up, right? You didn't have to log into a server. You didn't have to do. So if I'm, teaching a class on databases, this is a great place to start. Or if I'm giving a lecture and I want you to do something with a data set, right? I can just email you an SQLite database. Literally, I could just email you one right now. And you could just bring it up on your computer and it would just run. It's cross-platform. It works on everything. So it's really great for this kind of stuff. Okay, so if it's so great, why would we want to use SQL Server? Well, client-server applications, like a website with millions and millions of people, right? I want one server that handles a lot of stuff. I want to be able to back up that server. I want to be able to add multiple servers, redundant servers, high volume websites, very large data sets, right? So SQLite, one file is great, but say I'm running terabytes and terabytes of data, right? What if I am trying to predict the weather, right? That's terabytes of data. What if I'm an astronomist, right? That's terabytes of data. Can I put terabytes of data into one file on most operating systems? You're going to start bumping up into some limits. So if you have very large data sets, you need something that can handle that well. High concurrency, like we talked about, lots of people reading and writing at the same time, and distributed systems. So for example, say I run a financial firm and we have offices in London, Tokyo, New York, and Stockholm, right? How would I do that with SQLite? It'd be really hard, right? Whereas with an SQL server, I can literally put an SQL server in each location, tell them that they're supposed to replicate with each other, and they'll just handle it. Obviously, there would be some tweaking involved, and we'll get into that later in the course. But for purposes of comparison, if you need data distributed across multiple locations, you're not going to be using SQLite. TLDR, SQLite, small and portable. One application, one file. SQL Server, large and scalable. You can do all sorts of stuff with it. Any questions on the differences between SQLite and SQL Server type of systems? Awesome. All right, so the second half of this lecture is going to be Introduction to Git. So how many people have used Git? It seemed like a bunch. What class did you use it in? Software engineering. Okay, so those of you that are just starting software engineering haven't used it yet. Use it in data structures too. Okay, so then I'm going to go pretty quickly through this since you guys are probably pretty familiar, but some people haven't used it. So this is how Git looks on your local machine. You have one folder or one directory, right? This is the Git repository. You check out your project into your working directory, you stage your changes, and then you commit it back to the repository. So there's actually, this is actually a bad diagram for, I brought my own marker. We learn from experience sometimes. I actually really like the quote, we learn from experience that we never learned from experience, but I did learn from experience. So here's something like GitHub, which we will use, or Bitbucket, or something like that. You have your local repository, local master copy. This is called the origin. And then you have all the files that you've changed, which are blah, 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 blah. This is you programming over here. So what you do is you change a file, and then you commit to the local master copy. This is on your machine. Then you change a file, commit, change a file, commit, and then once you're happy that this is the way you want it, at least you finished the day's work or something, then you can push it back up to the origin. And then the next day, you make more changes, you commit them, and you push. So if you use Git inside of an IDE, right? So I use Microsoft VS Code. It is the first Microsoft piece of software that I have actually chosen to use in more than 20 years. But I highly recommend it, VS Code. I've used a lot of IDEs, but anyway, so if your IDE, some of them integrate Git already. Which one do you guys use for Java? I can't remember. IntelliJ? It has Git integration as well, right? So anyway, something that it might do is have an intermediate step here called staging. Staging. I can spell sometimes. Staging, right? And that's what this is talking about, is staging your fixes and then committing them to your local repository. This is kind of optional, staging. Doesn't really matter. The point being, at the end of every day, what I would recommend is pushing your code up to GitHub, because that way you know it's safe. You can work on it on any computer, push it back up to the origin, and then pull it back down on any other computer. So here's some terminology. Origin is GitHub in our case. It might be Bitbucket, might be something else, but you can actually make your own. It's really easy. If you want to set up an Amazon Web Services server for the free, or if you have your own server somewhere, I use Linode, you can set up your own Git server. It's super easy to do. Anyway, but GitHub is free, so we're going to do that. So that's the origin. Master means the local master copy. So this is on your local machine. It's generally, it starts out with whatever was in the origin, gets pulled down into a local master copy, and then you make lots of changes. And once you're done, you commit it and push it back up. So pulling pulls all the changes down from the master, from the origin into the master. Staging gets your changes ready to commit. So IDEs often have this, where you stage your changes. It's just a way of saying, like, I'm ready to commit these changes, right? It's like, I've saved all my files. I am reasonably confident that there are no bugs in it. I'm ready to commit it to my local master copy. The commit command saves it, so then your master copy is officially changed, and then you can push those changes up to the origin. So, oh yeah, and then this last part here can fail. So when you're pushing, have you guys done any group work in Git? Okay, so are you guys familiar with branches? Yeah? Okay, excellent. So I'm going to talk more about branches for those that haven't used it later in the class, because it doesn't matter for right now. But this is the way everybody does software development these days. Any professional software developer will use Git to, even if they have no collaborators. Like, even if you are working by yourself, you will still use this. So that is why it is important. Lecture is going to be installing and setting up Git. So go ahead and go into D2L. It'll show you how to install Git, whether you are on a Mac or on a PC with Windows. One thing to be aware of is during the installation, it might ask you what the default editor should be. By default, it uses Vim, which is really annoying to use. I would highly recommend choosing something else. You can install Notepad++ or Sublime Text, or you might even be able to select IntelliJ. But when you commit your code, it asks you to use a commit message to say what you're doing, and if you don't do it right away in the command line, it'll pop up an editor, and it's nice to be able to use an editor you're familiar with, like Notepad. Just need to accept the assignment by clicking on the link in D2L. The GitHub assignment has both the link to GitHub Classroom, and it also has step-by-step instructions. So if you're already familiar with Git or GitHub Desktop, you can use those, get the assignment done. If you're not, or if you want to learn how to use the command line a little bit, then just click on those step-by-step instructions and it'll walk you through the details. Thanks. We'll see you next week.